Learning outcomes. After studying this module, you shall be able to know encryption and decryption process, difference between symmetric and asymmetric encryption decryption technique, classification of encryption decryption techniques, asymmetric encryption decryption techniques. Now the introduction. Encryption is the process of coding information which could either be a file or mail message in ciphertext, a form unreadable without a decoding key to avert anyone except the intended recipient from reading that data. Decryption is the reverse process of converting encoded data to its unusual unencoded form, plain text. When an operator encrypts a file, another operator cannot decipher and read the file without the decryption key. Put a digital signature. A form of individual verification confirms the integrity of the actual message. To encode plain text, an encryption key is needed to execute an encryption technique onto the data. To decipher code, an operator must have the suitable decryption key. A decryption key comprises of an arbitrary thread of numbers from 40 through 200 bits in length. The key imposes a decryption technique onto the data. This decryption technique reverses the encryption technique, returning the data to plain text. The encryption key will make it further difficult to decipher. For a 40-bit encryption key, more than 1 trillion probable decryption keys are present. Now, classification of encryption and decryption techniques. There are two kinds of key-based encryption techniques. First, symmetric encryption decryption technique, and second is asymmetric encryption decryption technique. First, symmetric encryption decryption technique. The symmetric encryption technique uses the same key for encryption and decryption, or the decryption key is easily derived from the encryption key. Second, asymmetric encryption decryption technique. The asymmetric technique uses a different key for encryption and decryption, and the decryption key will not be the resultant of the encryption key. Next is difference between symmetric and asymmetric encryption decryption technique. Symmetric encryption techniques encrypt and decrypt with the same key. Main benefits of symmetric encryption techniques are its safety and high speed. Asymmetric encryption techniques encrypt and decrypt with diverse keys. Data is encoded with a public key and decrypted with a private key. Asymmetric encryption techniques, also called as public key techniques, require at least 3000-bit key to attain the same level of safety of a 128-bit symmetric technique. Asymmetric techniques are incredibly slow and it is impractical to use them to encrypt huge quantities of data. Generally, symmetric encryption techniques are much quicker to execute on a PC comparative to asymmetric ones. In repetition, they are frequently used together, so that a public key technique is used to encode an arbitrarily produced encryption key, and the arbitrary key is used to encode the real message with the help of a symmetric technique. This is occasionally known as hybrid encryption. Now, next is symmetric encryption decryption techniques. Symmetric encryption decryption techniques can be divided into stream ciphers and block ciphers. Stream ciphers encode a single bit of plain text at a time, but the block ciphers encodes numeral bits, characteristically 64 bits in modern ciphers. and encode them as a single unit. Now we shall discuss about some popular symmetric encryption, decryption techniques. First, AES encryption technique. AES stands for Advanced Encryption Standard. AES is a symmetric key encryption method that replaced the commonly used data encryption standards, that is DES. It was the consequence of a universal call for proposals of encryption techniques delivered by the US government's National Institute of Standard and Technology in 1997 and completed in 2000. It has first-rate key setup time and has low memory necessities. Further, its processes are easy to protect against power and timing attacks. AES technique uses 3 key sizes: 128, 192 or 256-bit encryption key. Each encryption key size makes the technique to act to some extent in a different way. So the increased key sizes not only propose a greater number of bits with which one can scramble the data, but also increases the complexity of the cipher technique. Second is Blowfish encryption technique. Blowfish is a symmetric encryption technique planned in 1993 by Bruce Signer as an encryption technique. Blowfish has a 64-bit block size and an adjustable key length from 32 bits to 448 bits. It is a 16-round fistal code and uses big key dependent S boxes. While doing key preparation, it makes great pseudo-random lookup tables by doing numerous encryptions. The tables rest on the operator delivered key in a very complex way. This method has been confirmed to be extremely unaffected against various attacks like differential and linear cryptanalysis. Unfortunately, it is not the technique of choice for environments where a large memory space is not accessible. Blowfish is alike in structure to CAST 128, which uses fixed S boxes. The only identified attacks against Blowfish are based on its weak key classes. Next is CAST, CAST. CAST stands for Carlisle, Adams and Stafford Tavros, the inventors of CAST. CAST is a widespread 64-bit block cipher which is from the type of encryption techniques called as fistal ciphers. Currently, there is no known way of breaking CAST short of brute force. CAST is now the default cipher in PGP. Next is Data Encryption Standard, that is DES. Data Encryption Standard is a symmetric block cipher with 64-bit block size by 56-bit key. In 1977, the Data Encryption Standard, a symmetric technique, was accepted in the United States as a federal standard. DES encodes and decodes data in 64-bit blocks using a 56-bit key. It utilizes a 64-bit block of plain text as input and outputs, a 64-bit block of ciphertext. Subsequently, it continuously works on blocks of equal size and it uses both variations and replacements in the technique. DES has 16 rounds, meaning the chief method is repeated 16 times to produce the ciphertext. It has been seen that the numerous rounds is exponentially relative to the total of time needed to discover a key by a brute force attack. So as the numerous rounds increases, the security of the technique increases exponentially. Next is IDEA encryption technique. IDEA stands for International Data Encryption Technique. IDEA is a symmetric encryption method that was formed by Dr. X. Lai and Professor J. Massey to reposition the DES standard. Not like DES, although it uses a 128-bit key. This key length makes it difficult to break down by simply trying every key. It has been one of the supreme widely recognized methods for specific time. It has been used around several years and no concrete attacks on it have been printed in spite of frequent efforts to investigate it. IDEA is unaffected to both linear and differential investigation. Next is RC2. RC2 is a variable key length cipher. It was designed by Ron Revest for RSA data security. Its particulars have not been printed. RC4. RC4 was formed by Ron Revest in 1987. It is a variable key size stream cipher. It is a cryptograph with a key size of up to 2048 bits, that is 256 bytes. This technique is very quick. Its security is unidentified, but breaching it does not look insignificant either. Due to its speed, it may have uses in various applications. It receives keys of random length. RC4 is fundamentally a pseudo-arbitrary number producer, and the production of the creator is exclusively ORed with the data stream. For this reason, it is very significant that the same RC4 key not ever been taken to encode two dissimilar data streams. Next is RC6. RC6 is a symmetric key block cipher resultant from RC5. It was invented by Ron Revest, Matt Robshaw, Ray Sidney and Yuquin Lisa Yin to encounter the necessities of the advanced encryption standards, that is AES competition. RC6 encryption technique was selected among the other qualifiers to become the new federal advanced encryption standards. Next is SEED. SEED is a block cipher formed by the Korea Information Security Agency since 1998. Both the block and key size of SEED are 128 bits and it has a fistal network assembly which is repeated 16 times. It has been formed to resist differential and linear crypto analysis as well as associated key attacks. SEED uses two 8x8 S boxes and mixes the XOR operation with modular addition. SEED has been assumed as an ISO or IEC standard, and IETF RFC or RFC 4269 as well as Industrial Relationship Standard of Korea. Next is Serpent. Serpent is more rapid and reasonably secure block cipher formed by Ross Anderson, Eli Beham and Lars Knudsen. Serpent can work with diverse combinations of key lengths. Serpent was also chosen among other 5 contestants to become the new federal advanced encryption standard. Next is T, tiny encryption technique. It is a very fast and reasonably secure cipher formed by David Wheeler and Roger Needham of Cambridge Computer Laboratory. There is a known weakness in the key schedule, so it is not suggested if greater safety is mandatory. TEA is given in 16 and 34 round versions. The more rounds or iterations, it will be the safer but slower. Next is triple DES. Triple DES is a variation of data encryption standard. It uses a 64-bit key comprising of 56 actual key bits and 8 parity bits. The size of the block for triple DES is 8 bytes. Triple DES encodes the data in 8-byte portions. The idea of the back triple DES is to recover the security of DES by putting on DES encryption 3 times using 3 diverse keys. Triple DES technique is very safe. Major banks use it to guard valuable dealings but is also very slow. Next is Two-Fish. Two-Fish encryption technique was designed by Bruce Signer, John Kelsey, Chris Hall, Niels Fryksen David Wagner and Doug Whiting. The National Institute of Standards and Technology investigated Blowfish as one of the candidates for the replacement of the DES encryption. Next is asymmetric encryption decryption technique. Asymmetric encryption decryption techniques, also known as public key techniques, use different keys for encoding and decoding, and the decryption key cannot practically be derived from the encryption key. Public key systems are vital as they are used for transmitting encryption keys or other data safely, even though the parties have no chance to approve on a secret key in private. Some of the popular asymmetric encryption decryption techniques are as follows. First is RSA encryption technique. Rivest Shamir Edelman is the generally used public key encryption technique. It can be taken both for encoding and for digital signatures. The security of RSA is normally assumed equal to factoring, though this has not been verified. RSA computation occurs with integers module n is equal to p into q for binary large secret primes p or q. To encrypt a message m, it is exponentiated with a small public exponent e. For decoding the receiver of the cipher text c is equal to me, mod n calculates the multiplicative opposite d is equal to e raised to power minus 1. We require that e is selected suitably for it to exist and obtains c d equal to me into d, which is equal to m mod of n. The private key comprises of n, p, q, e and d, where p and q can be omitted. The public key contains only n and e. The difficulty for the enemy is calculating the inverse d of e is supposed to be no easier than factorizing n. The key size must be higher than 1024 bits for a reasonable level of security. There are really manifold incarnations of this technique. RC5 is one of the very common that is in use, and RC6 was a finalist technique for AES. Next technique is DiffieHellman. DiffieHellman is the first public key encryption technique devised in 1976 by distinct logarithms in a determinant arena. It permits two operators to interchange a secret key on an unconfident medium deprived of any prior secrets. DiffieHellman or DH is a widely used key exchange technique. In several cryptographical procedures, two parties desire to communicate. Let us consider they do not initially possess any common secret and thus cannot use secret key cryptosystems. The key interchange by DiffieHellman procedure cures this condition by permitting the creation of a general secret key over an insecure communication channel. It is grounded on a problem associated to discrete logarithms, specifically the Diffie-Hellman problem. This difficulty is said to be hard, and it is in certain instances as hard as the discrete logarithmic problem. The Diffie-Hellman procedure is usually considered to be protected when a suitable mathematical assembly is used. In specific, the creator component used in the exponentiations would have a large period, that is order. Usually, Diffie-Hellman is not implemented on hardware. Next is digital signature technique. Digital signature technique, DSA, is the United States federal government standard or FIPS for digital signatures. It was projected by the National Institute of Standards and Technology in August 1991 for the use in their digital signature technique adopted in 1993. An insignificant review was delivered in 1996 and the standard was prolonged further in 2000. Digital signature technique or the DSA is comparable to the one used by E1G Amal signature technique. It is fairly efficient, however, not as efficient as RSA for signature verification. The standard describes DSA to use the SHA-1 hash function exclusively to commute message digests. The foremost difficulty with DSA is the permanent subgroup size, the arrangement of the producer component, which bounds the safety to about only 80 bits. Hardware attacks can be menacing to some implementations of DSA. Next is E1G Amal. E1G Amal is a public key cipher and asymmetric key encryption technique for public key cryptography that is founded on the DiffieHellman key contract. E1G Amal is the predecessor of DSA. Next is ECDSA, that is elliptic curve DSA, is a variant of the digital signature technique, that is DSA, which operates on elliptic curve groups. As with elliptic curve cryptography, in overall the bit size of the public key supposed to be desired for ECDSA is around double the size of the safety levels in bits. Next is XTR. XTR is an encryption technique for public key encryption. XTR is a novel method that makes use of traces to represent and calculate powers of elements of a subgroup of a finite field. It is grounded on the original first public key crypto system, the DiffieHellman key agreement protocol. From a safety point of view, XTR security depends on the trouble of resolving distinct logarithm connected problems in the multiplicative group of a limited field. Some advantages of XTR are its fast key generation, much quicker than RSA, small key sizes, much smaller than RSA, comparable with ECC for existing security settings, and the speed, which is generally comparable with ECC for current safety settings. We'll end this module with summary. Encryption and decryption is the procedure for encrypting and decoding information in order to maintain the confidentiality, authentication and integration of information. Encryption and decryption are categorized into symmetric and asymmetric encryption and decryption. In symmetric encryption decryption, the key used for encoding and decoding data is the same. In asymmetric encryption decryption, the key used for encoding and decoding data is different, therefore it is more secure and difficult to crack. Thank you.